Hello everyone. In this video, I'll tell you a little bit about SQL Alchemy. SQL Alchemy is some professional-grade software for dealing with large data sets. In class, we mostly focused on pandas, and that's because pandas is significantly easier to use than SQL Alchemy. However, what pandas typically does is it tries to read the entire data set into memory and then do all of the operations there. This works well for reasonably small data sets, but when you move to larger and larger data sets, a more complex approach is required. And that's why people have built database software. Things like Oracle, Postgres, MySQL, and SQLite that can deal with very, very large data sets that you need to store on disk as you're doing the operations on them. What SQL Alchemy does is it lets you interface with these database software in a nice and easy way through Python. And in fact, it lets you use the exact same code to interface with different database software in the back end, exactly the same way that a modeling language can let you interface with different solvers if what you're trying to do is optimization. So SQL Alchemy is this middle layer between your program and the database software. So let's begin by taking a look at some examples to see how SQL Alchemy works. At the beginning of this file, all we're doing is importing SQL Alchemy. And the first thing that we're going to do is we're going to connect our SQL Alchemy code to the background database that's going to actually execute all of our data queries and data storage commands. Now, here, all I've done is connected to a SQLite database that's in memory instead of on the disk. But you would simply just change this string if you want to connect to a different database, for example, that uses Postgres or MySQL or Oracle or SQLite on a disk. You can do all of those things by just changing this one string, and the rest of the code would work exactly the same in all of those cases. So here, we've just connected to that backend database by creating what's called an engine. So that engine is what interacts ultimately with that database. The next thing that we're going to do is we're going to define some data tables. Now, there's many ways, like literally 1,000 ways, to interact with, define, and use data tables in SQL Alchemy. What I'm showing you is just one particular way that I like. And the reason I like this way is because it lets us forget about SQL as much as possible and just use Python to do everything. For example, define our tables, create them, drop them, etc. And the various other ways you might automatically read in the data table from the database, giving a name, or write some SQL on how to define that data table, etc. But this is just a pure Python way of doing that. So to do this, we're going to import a couple of modules in SQL Alchemy. So the first is this extension module, that's the declarative extension. And then we're going to import the object relational module that lets us map the database tables to Python objects. So in the first line here, what we're doing is we're creating something called a base, a declarative base object. And what this object does is it contains all of the little metadata that connects our Python classes to database rows. So here's an example of how to do that connection. So we're going to create a table of students. And in doing so, we're going to define all the attributes that a student has. So the first thing that we do is we make student be a class that inherits from this base. So this is important because by doing this inheritance, what we've done is we've associated the student table we're creating inside of that metadata that's all getting stored inside of base. Okay, so here we're going to say that the table name, the actual table that I want created in the SQL database, is going to be called students. And I could have put any string in here, but the usual rule that I use is that the class is just capital single and then the table is lowercase and plural, so student and students. So then we're going to define a bunch of columns that that table has. So it's going to have an ID column. So we do that here by saying it's a SQL Alchemy column. It's of type integer, and it's going to be the primary key on this table. We're going to have a last name that's a string, a first name that's a string, and the student is going to have some kind of major in school. So we're going to have a major ID that's going to be an integer, and that major ID is going to be a foreign key on another table. So here I'm saying that that's a foreign key, and it hooks up with the major's ID in the majors table, which we haven't defined yet, but later we're going to define a table of majors. Then we are going to have a score for that student, so something between 0 and 100, how well are they doing in their classes, and that's going to be a float. And there's many built-in data types in SQL Alchemy. So for example, you could do dates, you can do all kinds of different additional inputs on floats, like for example, how much precision do they have, etc., etc., etc. And all of this is very well documented online. Because SQL Alchemy is a professional package, it literally lets you access essentially every feature that any of these underlying database engines have in them. And because of that, there's a tremendous amount of complexity behind the scenes here. So just to compare with things that you know, in Pandas, Pandas automatically tries to do this column data type checking when we read in a CSV file. So we just said read in the CSV file, and it automatically created this where it checked what data type each of the columns has. Now you can do this in SQL Alchemy similarly by giving a table name for a table that already exists, and automatically this class can get created for you. I'm just not showing you that particular method of doing things because I want to also create the table as opposed to just simply using an existing table. So here, by doing this, I've literally defined the schema for a student, which is all the pieces of data that I'm going to associate with a student. And this final function, the representation function, is just a way to print a student to the screen. So for printing a student, I'm just going to print a little string that says what the student's ID is, their first name, their last name, their score, and their major. So similarly, let's define a major table. We're going to use the same uppercase single for the class name and lowercase plural for the table name. And this table has only two pieces of data in it, an ID that's going to be the primary key, and a name that's going to be the name of that major. We're also going to set up a relationship between the major table and the students table. In this relationship, we're basically saying that each major has associated with it a set of students. So this is how we're doing it. There's a relationship with the student table. We want to order the students by student ID. And for each of those students, we're going to send a back reference to the major that's called major. So this hooks up with this foreign key relationship that we had set up before to automatically match these objects for us. And similarly, at the end, we're just going to print out a major. So over here, through these two classes, we've essentially defined two tables in our database and the relationship between those two tables. Now let's actually put some data into our database. To do that, we have to create the actual tables. So here's one way to do it. You could just say base metadata create all, and this is going to create all of the tables associated with the metadata. So how does Python know what this is? Well, it's because student was derived from that base, and major was derived from base. And so when we did that derivation, base now knows about the student table, it knows about the major table, and this create all statement creates both of the tables. Or you could of course do this one at a time. So for example, here we're taking the major table and we're dropping it, or the major table and we're creating it. So now we have these two empty tables, the student table and the major table, and now we want to put some data into those tables. So to do this, we're going to have to connect to the database through a session. So to do this, we are going to create a session maker. So here it is. This is just a session maker out of SQL Alchemy. And we're associating that session maker with the engine that we created at the top. So that was that in-memory SQLite engine. And from that session maker, we can pull out a single session. Now this might seem overly complicated to you, but that's because you might have in mind a particularly simple way of interfacing with the database. In a professional kind of application, a single application might have multiple connections to the same database, and that's why we need these session objects. But here it is, we have a single session object, and we're going to use that session object to add some data to our table. So let's read how to do this. In terms of adding data, there's 1,000 ways of doing that. Let me just show you one. So here we're going to take the session that we have, and we're going to add a single major object to it. So how do I do this? I'm using my major class. So here I'm calling major. I'm passing an ID of 1 and the name operations research. I can pass in a second major, which is ID of 2 and the name mechanical engineering. There's many more complicated ways of adding objects into your database, but here it is. I've added the 2 majors, and similarly we're going to add some students. So we're going to add Ned, whose ID is 1, and his major is going to be operations research. So the major ID is 1, and that lines up with the ID for operations research. We have John, whose major is mechanical engineering, and Jane, whose major is operations research. Now, after we've added all of these objects, we actually have to do a database commit to make sure that this gets written out to disk. Of course, for us, everything's happening on memory, so nothing interesting happens here. But if we're doing some complex asynchronous multiple programs interfacing with the same database, doing this commit is actually a very important step. So here it is. We've written out everything to the database. So now we have a database with majors, students, a couple of majors, and 3 students in the database. So now we can start doing some queries. So let me just cut and paste this into IPython so that we can interactively run the queries. Okay, so now I have the database with our 2 majors and our 3 students. Let's take a look at the queries that we might want to run. So the same way that we had to use a session to add new objects into our database and commit the objects that we've added, we're going to use that session to query things. So let's do this first query that just says, give me all the students that are in the database. If I say, give me all the students in the database, it returns a bunch of student objects, one for Ned, John, and Jane, and these were our 3 students that we placed with the various IDs. So for example, if I can store this into all students array list, and all students sub-0, let's say that that's Ned. So Ned is now a student object, and it has various attributes like ID, first name, last name, and so forth. So that row in the table turned into an object in Python. Let's take a look at some other queries that we might want to run. So I was just giving us all the students, but we might want to do something more complicated. For example, give me all OR majors. So how would we do that? Let's take a look at this. So session query. So give me the student ID, the first name and the last name, and the major name. But make sure that you're matching up students with majors, where student major ID is equal to major.id, and only give me majors with the name operations research, and then give me all of those answers. So for those of you familiar with SQL, this directly maps onto a complex SQL statement. So let's see what kind of answer this gives me. So it gives me an answer that's 2 tuples, and the reason there are tuples now instead of objects is because I asked for very specific columns. I asked for only these 4 columns, so that's why it's returning to me these 4 columns: the ID, first name, last name, and the major. And it's for all of the operations research students that we had, which were 2, just Ned and Jane. So that's an example of a more complex query that you can run on your data set. Let's see what other kinds of queries we might want to do. So this is a way of just doing the query with SQL statement, but of course we set up that foreign key relationship. So let's use the foreign key relationship to similarly just pull out all operations research students. So to do that, first I'm going to run a simple query that says query the major table and give me the major whose name is operations research. Now instead of returning some list, just give me the first answer. We know there should be only one answer, so that's going to give me a single object. That's going to be the OR major object. So let's run that, and let's look at OR major. So that's an object that's just the operations research major. Its name is operations research, and then its ID is 1. And because we set up that foreign key relationship earlier, what I can do is OR major.students, and it returns to me all of the students that are associated with that major. For example, Ned and Jane. So why did OR major.students do this? It was because earlier when we defined our tables, I defined this relationship, that students is going to be this SQL Alchemy relationship with the student table. And I'm ordering the students by student ID, which is why these students got ordered by student ID here. So ID 1 and ID 3. So let's take Ned out of here. So N is going to be the 0th student, so that's Ned. And I might want to take a look at what's Ned's major. So if I do n.major, it gives me, well, Ned's major is operations research, and its ID is 1. So how did this happen? Why did n.major get set up? Well, that got set up because we had this back reference. So that's what that last back reference parameter to this function says, which is on the student, create a back reference to this and call that back reference major. So that's how come I could do n.major and it referred to Ned's major. So basically that relationship is essentially doing the equivalent of this complex SQL query that we ran earlier. Now SQL Alchemy is doing a lot of complicated things in the back in terms of translating these Python objects to SQL strings with which to communicate with the database backend. So sometimes it might be nice to actually see what the strings are getting created. So here what I've done is I've taken that query that says give me all the students, these particular column names for the students whose major is operations research. Notice that the one thing I've removed is the .all at the end. So here I'm just setting up the query and I'm putting it into an object that I'm going to call a query. So here it is. So a query is just this SQL Alchemy query object. When I do .all, that actually runs the query. Here, all we've done is set it up. And one thing you could do is just print a string version, a string representation of a query. And this shows you the complicated SQL statement that's going on in the back. So select students.id, students as students ID, students.firstname as students first name, etc., 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 from these two tables where this condition is true. So you can build up incredibly complex SQL statements by doing Python loops on these kinds of query objects. So that's something extraordinarily powerful. That's much more powerful than just typing out these statements on your own if you've done that before. So the one complaint you might have with this is that if you look at these conditions, okay, so this is the join condition, that student major ID has to equal to majors.id. But the second condition was that the major name has to be operations research, but operations research didn't get printed out over there. And so there's a little fix you can do on that. And the only reason you would do this is for debugging. But you could set up a little function here, so debug, but with inline parameters for your queries. It takes in a query, and then all it does is on that query object it accesses the statement and it compiles it with this particular option, which is that we want to do literal binds. So if I execute this function, or just define it in Python here, and then I do debug inline parameters for my aQuery object, and I print that answer, it's going to print that complex statement along with actually substituting the parameters here with major's name equals operations research. So in terms of debugging, then you could just take this statement, and if you have a SQL window, you can just paste it into your SQL window to see if that's working or where things are happening if your queries aren't actually returning what you expected them to return. So SQL Alchemy is tremendously useful, but also highly complex because it has a tremendous amount of flexibility that lets you do essentially anything that you want to do in SQL, but in Python instead. So just some things that might be useful to read is the object relational tutorial. So it has all kinds of information here on creating different kinds of engines, defining these classes that are basically your various tables, using schemas, and so forth. So I can let you read that on your own, but other things that are useful to read is, for example, you could read about different engine configurations. So here's the string that you would pass in to connect to a Postgres SQL. So you can even pass in usernames, various passwords, and so forth. You can read about all the different data types that are built into SQL Alchemy. So big integers, booleans, dates, date times, time zones, etc., etc., etc. And just to give you an example of how pervasive this particular module is, it's used to run websites like Yelp, Reddit, Mozilla uses it, SurveyMonkey, Fedora project, and so forth. So these are major organizations that rely on SQL Alchemy as a backbone for interacting with their databases. And very likely it has the complexity and the efficiency to handle whatever large database project you have in mind that goes above and beyond the things that we did in class with pandas. So thank you very much for listening, and I hope you find this quick tutorial on interfacing with SQL from Python useful. By the way, in addition to SQL Alchemy, there's many other modules that you could potentially use to interface with a database. But SQL Alchemy is just one that I found to be particularly useful in my development. So thanks again for listening.